Okay, let's get started. Before I start, I would like to acknowledge that the presentation was prepared by adapting some slides originally prepared by Professor Udita, Dr. Madhura Perumal, and Mr. Neil Herat. Okay, so for us, before I start today's session, I think you all are like maybe very interested to learn the new area that we are going to study today, right? So I have a small centering activity for you all. Students, did you all get in the chat a link?
Yes, ma'am.
Okay, can you please try to do this activity? Students, were you all able to open the link?
Yes, ma'am.
Okay, so what is it? What is it? What is it?
Puzzle.
It's a puzzle. Okay. Can you all try to see whether you can fix this one?
Yes, let's try.
Let's see who can complete the puzzle first. Okay. So after I get thumbs up from at least 20, we'll move to the next section of the day school. Okay. Okay, students. So what is it?
It's a function, ma'am.
Okay. So let's see what we are going to learn today, right? So we will learn a very important concept, introduction to structured programming concepts, like in theory, and then modular programming, function-oriented design. Under C programming, we learn about functions and an introduction to data structures. And finally, we'll start one stage of the software process model requirements elicitation. Okay, so now in late 1960s, long time back, isn't it? So there was a rapid development of hardware components. But then there was ad hoc software development. Although the hardware part was developed, the software development was not done as per the same pace. So it was difficult to design, write, and test, and virtually it was impossible to understand and to maintain. So there was a software crisis. Because of this software crisis, so there because this was not this was not something that was there for a long time, right? So when the softwares came, the software was introduced. So how to develop programs, how to write them, there wasn't any structured way. So that's why after the software crisis came, there was this development of programming method, structured programming, top-down programming, stepwise refinements, and so on, right? So now structured programming, it is following a structured methodology to carry out program design, implementation, and testing. It's very structured. We will have modules, module programming. It will have stepwise refinements. So that means stepwise we will, the execution will happen stepwise. Then level of abstraction is there. We'll talk about it later. Top-down, bottom-up programming. So start from top and execute one by one and go down, or the other way around. So this structured programming, not ad hoc development, structured programming provides verification of algorithm correctness to ensure program reliability, systematic programming process, then relating the programming task to the program design structure and the programming team structure, application of management techniques, use of abstraction, that means hide important details. Now, so in structured program, it's a program, we can say it's a program methodology, right? Structured programming provides these facilities. So it's a program methodology for constructing hierarchically ordered modular program using standard control constructs. Now we'll see, try to figure out these things, the puzzle one by one, right? There are a few new words to you, so we'll see one by one what those things are. First of all, I hope you all can remember what standard control constructs are. Standard control constructs, we talked about some of them previously, right? They are like sequence, selection, and repetition. Let's now have a look at modular programming. Now, generally, modules in a structured program are hierarchically ordered. So you know what I mean by hierarchical? So you have top boss here, right? Then you have, so think about an organization, you have a boss, and then you have assistant managers, and then under different assistant managers, you have different sections, no? Like this is what you call, in this one, this is a hierarchy, hierarchical order, bottom level, right? This is the top level. Now, simple programs may be organized sequentially, but it's rare given the complexity of programs. Yes. Simple programs, so usually, now look at this one. This is the main program. We have a root level, right? Then we have two modules, module one. Module one will take care of one section, and it has two components, 1.1 and 1.2. When it comes to module 2, it's another different component, and you have module 2.2. Right. Now, what are the rules for introducing, like what are the rules for using a module. Now, students, when you talk about modules, you can have, now look at this structure. Let's say this is the module that is in blue color box. Okay. So you'll have a one unique entry point. To enter into the module, you will have one entry point and a one exit point. Okay. Inside the module, it's a self-contained structure. So inside the module, you have the structure. It can be either a sequence, selection, or a repetition. It uses control construct, sequence selection, iteration. Then, very important thing, performs one logical task. What do you mean by that? Now, let's say students, we have a data set. We have a data set, 250 instances, and we are supposed to find the, let's say we are supposed to find average. And we are supposed to find standard deviation. I hope you all can remember these things, right? I've completed this in mathematics, isn't it? Standard deviation. Okay. Now, if you're going to program this, you're going to write a program for this calculation. Average and standard deviation cannot be in the same module. We have to have two separate modules because it says performs one logical task. So to find the average, the calculation should be done in a different module. Let's say module 1. Then you need to introduce another module named module 2 to carry out the tasks for standard deviation. Okay? Right. So standard control constructs. Now, this we have gone through before, right? We know that in the standard control constructs, especially in structured programming language, not object-oriented programming language. We will talk about that later. But in the structured programming language, the standard control constructs, we have sequence first. We have sequence. Then sequence is you execute instruction one by one. One by one. Execute this line, then execute this, then execute this and this. That's a sequence. Then we have selection. So we have this, see, we have this decision box. Then we have true and false. So you accordingly, you can execute the relevant branch. Then you have a repetition structure. So you repeat until a condition is met. Like we have to maintain, let's say, you want to get count 5 times. So you, until the counter is not 5, you can carry out the tasks. And if it's 5, you exit this repetition structure. Okay, so then let's take modular programming example. So we have an update master file for an example, right? We have update master file, and then in the next level, we have different modules. Get valid transaction, that's one module. Fetch master record, that's one module. Update master record. Now, can you see here? You have get valid transaction. You have a, see, you come here and then you enter here and then you move out from here, right? So that's the communication between the update master file. Then get valid transaction module. Now it has two modules. So in order to talk to each module, it should first have a input and output place, right? For this module, for each module, you should have exit and entry points. Okay, fine. This is done. Then for this print error message, then you should have another exit and entry point. So, right? So you print error message, you have an entry point and you have an exit point here. Okay. So let's get update master record module. Then in that module, you have different other modules in the next level, like add record, modify record, delete record. So these records, say for each module, you have an entry point and an exit point. Okay. Right. So I hope that you got an idea. Like when you look at a program, you should modularize it. Modularize it for the purpose of easiness. First of all, it's very easy to handle them. We need to have a structure, isn't it? That's what structured programming, we have to have a structure. So we have this hierarchical module because this is a structured programming language, right? So we have these modules identified. So you can say for add record, a separate function. For modify record, a separate module. Sorry. For delete record, a separate module. So you have exit points and entry points. Students, did you all understand this concept? Yes, ma'am. Only one person understood. Excuse me, students. So how many of you all understood? Can I have some inputs from y'all? Only 3, 4, 5, 6. We have 250 students today.
Excuse me, ma'am. Can you explain again?
Hello? Yes. Harini?
I can't understand, ma'am. Can you explain again?
Yes. So we have the modular programming concept here. I'll use this example to explain to you, right? So when you're given so in a program, you should always, if it is structured programming language, like you're using C, right? It's structured. And here what you need to identify is you need to identify each module. Identifying each module means you have to, as mentioned previously, in modular programming, you have to have an entry point and you have to have an exit point. And it have to perform only one logical task. So if you are supposed to find average and standard deviation of a set of data, then you need to have two different modules. One for find average, one is find standard deviation. And inside the self-contained structure, that means everything should be there inside the module. It's self-contained. Then there you will have control constructs. See, it may be sequence, it may be selection, it may be iteration. Okay? So because why we have structured programming? Because it is very easy, right? And it is also so that because we have a structure, right? It follows a structured method. So we have a hierarchical, ordered set of modules. And because these are like when it comes to this decomposition, right? That means breaking down the tasks into small tasks and carry them out in separate modules, make our job easier, isn't it? What do you all think? So you have a very big task to carry out today, right? Let's say we are going to cook. We're going to prepare a meal, and let's say we're going to prepare 4 curries, right? Okay. So now if we have, let's say we are going to prepare this for 200 people, right? We have to prepare 4 curries with rice. And if we have 4 more, let's say we have helpers, right? Then these curries we can give to different people. Now we have 4 helpers now. So helper 1 will do the first curry. Okay. Helper 2 will do the second one. Helper 3 will do the make the third curry. Helper 4 will make the 4th curry. Now what did we do? We distributed our work to 4 helpers, so that this helper 1 will make, let's say the helper 1 is going to make dal. We'll get the dal curry from the helper 1. Helper 2 will make potatoes, right? Then helper 2's job is to cook this and nothing else. Same way, we are going to get different modules. Add record a different module. Delete record a different module. Modify record a different module. And these 3 modules, we'll have it under one module called update master record. Okay. So these are different modules. Then let's say get valid transaction. To get a valid transaction, we have to, what do you have to do? Let's if you can remember about the ATM example I mentioned the other day. So when you take the ATM machine, so you need to enter the PIN number, right? So how do we know whether this is valid? So first of all, there are 2 components now. So you go to the ATM machine, right? You enter the card. Let's say it's a card, a transaction with the card. So you enter the card and then you need to enter the PIN number, right? So you enter the card is one function. Then you insert the card. Then enter the PIN number. That's a different module. For entering the PIN number, what do you have to develop? You have to ask the user to enter a value, isn't it? A PIN number. If after entering the PIN number, you have to check whether it's valid or not. Now, if it is wrong, we need to print an error message. So check the validation. For validation. If it is true, fine, otherwise an error message. So there are 3 components here. Inserting the card, entering the PIN number, checking the validity, and print the appropriate message. Do you all understand this now?
Yes, ma'am. Now understood.
Yes, ma'am.
Right. So we'll move to stepwise refinement. This is a little complex concept rather than the modular concept. Try to understand it, and you can always read the book and later on discuss again. So we have, let's say, why do we do stepwise refinement? It's very important to understand. That is because we are going to use stepwise refinement. As we do it, we use the same piece of code, right? And then carry out these tasks one by one. So here start input A, input B, multiply A and B using addition. We don't multiply A multiplied by B, but we are used by addition. So if you're going to do this one, it's going to be stepwise. Have to do it many times, isn't it? So we have to carry out this task stepwise. We will use this piece of code. This as a repetition many times, right? It's a stepwise. We do it many times. So this is some, like there are different concepts of, so like modular programming, and this is one concept, right? Right. Function-oriented design. Now, function-oriented design is a method to software design where the model is decomposed into a set of interacting units or modules where each unit or module has a clearly defined function. Thus, the system is designed for a functional viewpoint. Yes. So now think about that ATM machine that I talked about. Here, this also we can do it as function-oriented method, right? So we can have like, we'll always think about the task or the function that we need to carry out. Okay? Think about the function that we need to carry out and then execute instructions one by one, right? So we'll talk about it more when we write programs. Now here, now structure charts. Structure charts is a way of representing writing programs. So this is not very much used nowadays, but as software engineering students, we should know that this type of a concept was there for some time, right? So we always can use structure chart. We always can draw structure charts, and at any time you should be able to draw it as well. So this is not very popular these days. So we have one module and then sequences one by one. So first execute this, then execute this. So if we have a third component, it should go here, right? So because in the structure chart, the sequences are shown like this, horizontally. Okay. Then selection, you will have the modules, but you have this circle. So saying this is a selection. So it's either S1 or S2, right? And an iteration, it will be just a colored one, saying that you have to be in the same place, you iterate or repeat. Okay. So then NS charts, this is also something that is not very popular these days. Somehow as software engineers, we should know about this. So sequence in NS chart, each step here you can see is explained one by one from top to bottom. That's a sequence. And a selection is where you have the condition here. You put the question mark. If it is false, what to do? If it is true, what to do? Right? We have discussed about flow charts, so keep that in mind and think about this, right? The iteration. So the iteration, there are different ways. See, you can write until a condition is met. Until a particular condition is met, you carry out the tasks. Or while a condition is true, you carry out tasks. Okay? Okay. So these are different ways of showing the structured programming. right? So the different diagrams that were introduced in some time back to show how to depict how this structured programming is done. Okay, now we'll move to the variables, logical operators, control constructs, functions. Yeah, then C programming, right? Okay. Actually, during the previous day school, we discussed about variables, operators, control constructs, and many more things, right? So we have to today discuss, I stopped from functions, right? So we'll see one by one how to do this, right? So in functions, now I'm going to explain this function, okay? This, now, let's say we have a main program and we want to find the addition of two numbers. For simplicity, we'll consider the values given by the program itself, right? And so we have a separate function called addition. This is addition. This is our function. So we give this is our main program. We get help from a different function. So when we call the function, I hope you can remember that I mentioned early on, so with your previous day school, that when we call a function, we are calling, right? We call a function and the function should execute the work and return the value. Can you all remember this concept? I said you call the function and then you return. Right? Let's see. In this program, we have the main program. We have a variable declared int answer. The answer is equal to addition, open bracket 5, comma 15, close bracket 15, and semicolon. So I'm talking about this, right? What is it in light blue color, right? Here, this one. In this case, what are we doing? We can see, first of all, there are two components, isn't it? Left-hand side, right-hand side. So, as mentioned the other day, this one, we have an equation sign here. So, we have two components. No? So, we have two components. When we have the equation sign, I mentioned that whatever you have it on the right-hand side, the equation will get executed. It will get executed. And what will happen? Will get assigned to the left-hand side. Can all of you all remember this concept? You all remember this? Can I have some feedback? It's like I'm talking to a wall. No one is responding. Only one. I have only 8 inputs. Like I have 250 students and I'm just like talking to a wall. I want you all to talk, students. Now, if you all have a complaint to do, you will be talking now. You will not keep your mouth shut the same way. If you understand, say yes, you can understand, you can remember, or you don't understand, please participate. Okay, so when you have these two components, that right-hand side should be executed first. Okay, so we'll execute that part first. This bit should be executed. So what does it say? Addition, open bracket 5, 15, close bracket, comma. So now this is the function. This is a function. We are calling the function. We have a semicolon here. You have a semicolon here. That means we are calling a function. What is the name of the function, students? What is
Addition.
the name? Addition. Good. How many parameters are there?
2.
2. 5 and 15. Right. So we are calling this function. So when we are calling, what are we sending? 5 and 15. 5 and 15 are the 2 arguments or the parameters that we send to the function. Okay. Right. So we have the main function. We have a answer as declared. Then we have this one. So in C, right, for the ones who missed and who wants me to explain this again, because there are some students have put it on the chat. Remember these concepts, okay? I explained this one the other day also, that when you have an equation sign in C or in any other programming language, for that case, right, it will be always, you have 2 sides. Whatever you have it on from the equation right-hand side and left-hand side. It's not like in mathematics where left-hand side is equal to right-hand side and right-hand side is equal to left-hand side. That doesn't work anymore in programming. It's a different way. Here what it says is, you have the equation sign, whatever you have it on the right-hand side should execute first. Remember that, execute. It should happen, execute. And then the value should, whatever after the execution, after the execution, a value should be returned to the left-hand side. So the other day I mentioned that, like, you order, can you remember? What did we order? Hoppers, right? So you order hoppers and then we get hoppers, right? Right. So you execute this, get a value, and then assign to the left-hand side. Right. So now that's what we are going to do. Here, first, we call this addition function. Addition. So we come here now. We don't think about the answer right now because we need to execute this part. So the compiler should first execute what is given on the right-hand side. So because it's called, it will come here. Now, students, can you all see? The main function ends here. The main function ends here. Which is the main function. Right? What is, put it in red. So in green. Okay, let's take purple. In purple, I have the function here. So now the name is addition. The argument, here it's 5. Here we have a name. See, when you write a function declaration should always have names in the arguments. It should have a data type of this argument, number of bats. Okay, the 5 is actually number of bats there. So it's an integer value. Then we have number of balls. It's 15. So it's an integer data type. So always when you write functions, you have to have function in the function parameters, what we are expecting, what is the data type we want. And then this is obviously this is the function name, addition, and see arguments or parameters. There are 2 parameters, number of bats, number of balls. And what is this? In front of the name addition, you have return data type. So I think I mentioned this. Before as well, but I'll quickly touch on it. Return data type means any function should execute whatever that is written inside when the close when you see this closing of the curly bracket, that means the function is over. Whatever that is executed and whatever that value that you got, if it's needed to return, you need to write here the return data type. If after executing you are returning just one character in the alphabet, then you have to put char. Okay. If you are returning a float value with decimal places, then you write float. If you are returning an integer, write int. Okay. So there are when declaring a function, there are mainly 4 important components. When declaring a function, the first thing is the return data type, number 1. The function name, parameters or arguments, then the function body. So always when you are asked to define a function, you have to write the name. If you this is only declaration of the function. I'll come to that later. When you define the function, that means you explain everything in the function. So you have to have the return data type, number 1, the name of the function, number 2, parameters, number 3, and whatever you are supposed to do. That's number 4. That's the process of the function. Okay, let's see what we are going to do here. We have introduced a variable called total. It's also an integer, and the number of bets plus number of balls, you get the answer and you return the value. Returning also, you are returning an integer. So you have the return data. This is the return value, total. Okay. So now, where will this answer go? Students, first, where will it go? To A or to B? What do you all think? So it's called from B, no? It's called from B and you get the answer to B. Okay, not to A. So when you call, it will have what will happen is this will execute. And then this is, I told you this will execute and the value will get assigned to answer. So finally, when the compiler execute this line, finally the answer variable will have a value here. Okay, then you can print this one. I don't have to explain about the printf statement. So we had the practice session also yesterday and we did the day school and you all know how to write a printf statement by now, right? That's good. So function declaration, that is something else. So that is like when you start the program. The compile, I think I mentioned in C programming, it's always from top to bottom. We have to write the functions. Now, the compiler will look into this one and understand, okay, there is going to be a function. It's only a declaration. It says, okay, what is the return type? What is the name? What are the parameters? Not the definition. What happens inside the function, the component, that is written here. This is known as function definition. Okay. Now, students, I want you all to do a small activity. Before that, let me quickly show you how to execute these functions in C, right? So students, you also can write the program, and I think you all have your book for 3467. You can write your program there, okay? Let me share my screen with you all, and then we will write this program. So we have in addition, and then we can have two variables. Okay, then we'll have the void main. So then we call this function. So yeah, we get answer as the variable, and we call the function addition with some values. Okay. Let's see. The total is 20. Yes, because we have only one printf statement here. Now, we are not asking the user to enter values. It's given here. And accordingly, the answer is 20. We don't see what's happening inside, right? We don't see what's happening inside the program, but we say get the answer here. Okay. Now let's change this one. I'll make it to 60 and this to 10. Okay, students, did you all see? Right, what's happening inside? We don't see it, right? But then it's what we will do is, right? So the addition of 10 comes here. Sorry, the 10 value comes to number of bats, 60 comes for the number of balls. So make sure you give the order properly, right? It will only understand from the order. Always remember, computer is a dumb machine. We are the intelligent people who will be programming using this dumb machine, right? We are going to make, we can't make a machine intelligent, but we have to write programs in using our intelligence so that it will work, give us the answer as we want. Okay. So you have to be very careful not to mix up these values and get it, right? So for the total, so it will take this value, it will take this value, execute, as I mentioned, always when you have equation sign, first execute what's on the right hand side, execute it, and then assign it to total, and then return total. Okay, students, I hope you got, because all the other things other than this function, you will have learned in the other previous sessions. So now you learned about this function, right? Okay.
Excuse me, madam.
Yes.
Madam, if you write the function before the main function, is it a problem, madam?
Sorry, can you repeat the question again?
If we write the addition function before the main function, madam, is it a problem? Is it a problem, madam?
Okay. So now, see, in all programming languages, right? There is this thing called, I think I mentioned the other day also, that we have something called good practices, isn't it? Right? So the best practice for writing structured programming languages is top to bottom, right? Then when it comes to object-oriented programming, it will be always from bottom-up approach. The main program will be in bottom, in C programming, C++, Java. Okay? So always when you have to, like, because this is like you're learning a concept, right? So you always have to follow, because this is also like this is engineering now. So you have to always follow what's the standard is, right? When you're writing a C program, the correct way is, because the compiler starts from here, moves step by step. It will check the main program and then execute from there. So you have to write the main program here in C, and then write the rest of the modules or the functions one by one after that. Okay? In object-oriented concept, it's the other way around, where you have write the main function at the bottom and the other functions on top. Did you all understand?
Yes, madam.
Whoever who asked this question, did you get it?
Yes, madam.
Okay. So when you're, okay, so that's it. I want you all to, okay. So this is the first day school activity. Now, students, please write a program to find the largest of two numbers using a function. Now, writing this program without a function, you are aware. Actually, we did a very similar question yesterday also during our practice session. So write the program, but using a function, right? I will give you like 5 minutes. Right? If you can check with your program with the computer, or you can just write the program on a piece of paper and I will check the answers. And you will have to switch on your camera and show your answer to us, all of us. Okay, I'll give you 10 minutes. Okay. Okay, students. So I can see some answers. So the ones who have written on a piece of paper, right? Can you all please raise your hand? Anyone written on piece of paper? Okay. So one student who has not learned C before, and you learned it only from these 3, 4, 6, 7 sessions. Any student? Can you all voluntarily switch on your camera and show your answer? Hello? Harini? Very good. You have not learned C before? Harini?
Yes, ma'am.
Have you learned C before coming to this course? Harini? Harini, can you hear me? You are on mute, Tarini. Okay, so we'll get someone else then. If you have a connection problem, we can get someone else. Sumudu? Sumudu Ratnatilaka. Sumudu. You are there? Vimoksha, are you there? Amanda, are you there?
Yes, madam.
Okay, can you show your answer?
Madam, I can show, but when I ran it, it didn't work.
Yeah, that's okay. We will discuss about it. Have you learned C before coming to 3467 course?
No.
Okay, good. Then I want to see whether you understood it properly. That's why I asked that question, right? Okay, so can you please show your answer? We'll see what happened. Focus it more. No, it's not clear. Okay, so where is the function? I can see
The main.
This is the main function.
One. Yes.
So you wrote only the main function?
Yes.
No, you have to write the function now. So where is the biggest function? Your name of the function is biggest now? Where is it?
Yeah, the second line, madam. Int biggest. Because it's an integer.
Yeah, but that is the declaration only now. You have to write the definition also of definition of the function. The body, where is the body of the function?
That I didn't write, madam.
That you need to write, okay? Is there any student who wish to share your answer like that? I can give my comments like this. Any student who has not learned C before? Dumindu? Dumindu? Rajapaksha? Dumindu? Are you here? Yes, ma'am. Okay, do you have your answer with you? Have you got an answer? Chat box, in chat box. The chat box. Okay, Dumindu, can you copy and paste, and I will give you sharing. Okay, put it to the chat. It's okay, then we'll discuss. Have you learned C before, Dumindo?
No, ma'am.
Okay, put it to the chat, then I will get it from there. Can you put it to the chat again? I can't find your one. Have you done it, Dumindo?
Yes, ma'am.
Okay. Right, I will get this one. And let me show you. Okay, let me share my screen with you all. So I'm going to take the program that Dumindo has written. Go to test activity, edit. Now I need to give a name, so I'm going to give the name as I hope you all can see my screen, right? So it's int biggest, int main, ab, enter two integer numbers. Function called biggest of the biggest. So did you write this one on your own, or you got it from somewhere else?
I write it in on.
Okay, then good. So now this has used some complex things, so I don't want to do this program, right? Because we have to first learn with the simple things. But I will explain what he has done, right? So let's see what is the answer here. Enter two integer numbers. So I'll enter 5. Let me see. 5. Biggest of 5 and 6 is 6. See, you got the answer, right? So he has used some of the things some things like this, which you may have learned, which actually by now you should have learned, but maybe you have not practiced this. Let's start from the beginning. So it's the main. So this is something that students you have to do. You have to, please don't write it like this, right? So you will lose marks, right? So I'm telling you, you have to write like this. When you write the function prototype or the declaration of the function, the argument should be there. If you write only the data type, you will lose marks for your test. Okay? You can't see my screen? The program?
Yes, ma'am.
Can see.
Can you all see, or you can't?
Can see, ma'am.
Can see, ma'am.
So you have to write the data type and the name, right? Although this will work for this compiler, it will not work for all the compilers. So when you are writing programs, make sure you write the complete program, not halfway, right? So you have to write the name, the arguments. That's important. When you, like, this is one thing that I wanted to highlight, students, especially these concepts, software engineering concepts, then C programming, they are so popular with software engineering students, and there are so many wrong web pages with web resources, with wrong programs, with wrong concepts out there. So when you write programs, or anything, learn the correct thing, right? If you learn the correct thing, because that's why I don't recommend any web pages out there. Anything I won't recommend. I'll recommend only very few, because most of them are using wrong concepts, right? So whenever you write a program, a function prototype, or a function declaration, it's important that you write the variable names, because some of the compilers don't use it. Okay, so then in this one, the main, then you use A, B, enter 2 integer values. Yeah, so you can enter like this, but you can write this in one line like this, or you can have 2 values, you get it separately. Okay, so there are, some of the students are complaining that they don't have the edit functionality. Let me save this and go back and see what the issue is. Okay, students, can you all please refresh and then check whether it's working, or get it on a separate browser and see whether it's working now. Okay, students, can you all please check whether it's working right now? Can I have an input? Is it working? Okay, so the ones who are not working, please go log out from the LMS and log in again. Students, check whether it's working now.
No, ma'am, it's not working.
Please log out from the LMS and come back again.
Yes, did ma'am, but it's not working.
So are you all checking Day School 3.2?
Yes, ma'am.
Did you all
working, ma'am? It's working.
It's working now. Yes, it should work. It should work now. I have fixed it. Check again. The ones who don't have saying no.
It's working, ma'am.
Yeah, it's working now. So okay. So hope you can see this one. So you can write this printf in 4 lines rather than in 2 lines like this. Right? Then you can call the function biggest. So now this is like like, because see, this one is like you have used many things together, so you don't need to do like that because it's complicated for some of the students. So I will make it very simple, right? So biggest of this first A and B is also a total value. We'll get rid of this one, make it very simple. So what is best is like we call the function before. And then we can have it. Then we can have this as an integer. So this is the structure you need to remember. The other structures you can always, like what he has done, this student who showed his work, like Dumidu, right? So you can do it like that, but make sure you don't complicate things, right? You can always do like this, a very simple way, right? And this also, this he has used a, what do you call it? There's a shortcut, right? So you don't have to write these things. You can write the code for checking using if-else statements, right? You can write them using if-else statements very easily, right? So this is too complicated for a person who starts programming first, but if you start practicing, then you can come to this level, okay? So students, can you see in the program? So you can ask, enter two integer values, and then this is very important, right? So when you're doing the lab test, read the question very carefully. If they say, okay, use a function and save your work in a separate variable, then you have to do this method where you save your work on a separate variable. Like the earlier, what this student has done, it was not using a separate variable, okay? Okay, so you can try your work in any virtual lab that is available, okay? So enter two integer numbers. Yeah, see this, you get the same answer, right?
Excuse me, madam.
Yes.
Madam, in that last comment you had written if-else statements.
Yeah.
So it's like inside the return we have to write if x
No,
is
no, no,
greater
no,
than
no, no. Instead of this. So you can say instead of the above statement, right? Statement, you can write if-else statements, okay?
Okay, madam.
The day school recording will be available, but if you want to open the day school recording, you will have to answer the day school questions, right? Then you can open the recording, right? Recording will be available. No, day school 2 recording is not uploaded yet. Day school, you were supposed to attend the day school, not check the recording, right? So it will be open when you, after you try the quizzes. Okay, after you try the quizzes, then you will see the recordings. Okay, so I can Yes, that is another good answer. Let me see whether it's good or bad. Okay. Let's get this answer and see. So don't write like this. This is wrong, right? I mentioned the other earlier also. You have to have your main function on top, then the functions after that. And before the function, please make sure you write the function prototype. So please follow this method, right? Always have the function prototype on top. You have the main function, then later on have the function definitions, right? So marks will be allocated for following this structure. You don't have to write this. Yeah, this is a very simple program, nicely written. Here, so you have the void main, num1, num2, the largest. Then we ask the user to enter two numbers, num1, num2. Then you call the function find largest, right? So please put some comments. Okay, marks allocated for writing comments. So I hope you all are following what I'm doing, right? So you, of course, your answer, there will be many different answers. You can't write the same way. You won't get the same answer. So when you do the lab test, make sure you don't copy from someone else, okay? Because if we find that you have copied, you will get 0 marks, right? You get 0 marks if you copy. It's very easy for us to find if you have copied or not, okay? So please don't copy, write your own program. That's why I don't want everyone to be write very complicated. If you understand simple programs, write simple programs. If you think you can write complex ones, write in the complex way, right? But not any two of the students can have the same program. You will never have it. Because see, the variables will change. Then the way that you write the program, the way that you structure, everything is different. Okay? The way the comments are written. Okay? So you have to have your own programs written in your own way. Right? So please try to, now when you take a program like this, you also take down this program if your answer is not correct, if you're not getting the answer, and then what you can do is change these programs and see how you can modify. But one thing, remember, using correct practices, using correct methods. So as I told you, sometimes some of the compilers are already built in, then they don't use these names. They don't use the header files, but you don't do like that. You have to write complete program. Okay? Right.
Excuse me, madam.
Yes.
Madam, you may feel like hitting your head on a stone for me asking this. But in the two programs that you showed, The earlier one, the void the main was void and the other one was main was int. No. What's the difference?
No, so what's the difference? You can either have it as main or you can have a int, but if it's int, you have to have return 0. Right? I think I have explained
Right.
earlier. Right? It should
If
be
it's
return
void,
0.
that requirement is not there, no, madam.
Sorry?
If it's void main, the return 0 is not there.
Not there. No.
Okay, madam.
Right? It's not there. It shouldn't be there. Okay. Now, you all can't still access this. It's so funny because when I check from the student mode, I can see it. I can see the edit without any issue.
Uh-huh.
Okay, we'll look into that run options and edit options later. I'll go through the day school, right? Right. So we have something important to discuss now. This is about data structures, right? So can you see my screen, students?
Yes, ma'am.
Okay. So there are some data, there are something called data structures, right? Now this is very important. You have, I think, another module in next year. Actually, not a module, another course called data structures and algorithms, where you learn this section very deeply, right? But for now, I will just touch on this one. Of course, we'll get some questions for the labs as well, but not for the first lab, of course. So we have arrays. This is one data structure. It's a very simple data structure where this is the derived data structure. That means from a basic data type such as int or char, we can derive different data type. So these are data structures. We call them not data types. We move to this new thing called data structures. It's a structure. Now, this one, let's see how to declare a data structure, an array. So here is the so this is the array name, my array. And this char is the data type. And 10 means we have 10 elements. We can store 10 elements. Let's look at the next example. The name is number array and the data type is int and the number is 10. So you can store 10 values. It's not a one variable. It can store 10 variables at a time. Whatever. 5, 6, 7. So this variable can store 10 values like this at one time. Okay, so when we are trying to work with arrays, we have to remember that even to enter values to an array, also and view values from an array, it's easier to use for loops. Okay. So when it talks about arrays, we have indexes, right? We have an index. So, and we've got values and we have the addresses of it. So let's take an one example. So let's say the first value is 100, then 99, 200. Okay, so I declared an array called int my array. Okay, 3. Right? So then if I put these values, this is known as the 0th index. Always array starts with 0. First index, second index. Okay. So 0th value is 100. First value is 99. Second value is 200. Okay. That's how the arrays are structured. Okay. Let's take an example. So we have the example. So int main, array of 10 integers called number array. Okay. Right. So before I do this example, I think we can take a screen break because now it's 12:30. Okay. So it's 12:30. Shall we all meet at 12:40? Students? Then Alex.
Okay, ma'am.
Okay, ma'am.
Okay. So we'll have a small break, screen break. That means do not write C programs now. Do not check your phones. Do not check your emails. Right now, what you're supposed to do is get up from the place where you are seated, and then you have to take your eyes out from the devices, take a 10 minutes break, have a cup of tea and come back at 12:40. Okay. See you then.
Hello.
Okay, students, break is over, right? So I hope you got a good small break. So let's start. Can all of you please check whether this LMS, whether the virtual programming lab day school 3 is working? It should work now. Can y'all please check whether lab 3 day school 3.2 is working? Are y'all there?
It's working, madam.
Yes, ma'am. It's working.
Yes, ma'am.
Okay.
Run option also available.
Sorry, I didn't understand.
Run option also available.
Sorry?
Run option also available now.
Now available, no? Okay, that's good. So I think we can start the session now, right? If everything is fine, let me just... Okay, let's have a look at this array example. Okay, students, first of all, like any other variable, an array variable also should be declared, right? If needed, you can initialize it according to the program. You may initialize it. Okay, so students, so edit option is available, right? Some of the students are saying it's not available. Can you all please refresh your browser and see what's the issue? It should work because it's now everything is set. Log out from the LMS and relog. Yes, that's a very good option because it's working now. Okay, so I think we can start arrays. Here in the arrays, sorry.
Madam, edit is not available for day schools. For the others, it's available.
Day school 3.2, it's not available?
It's available, ma'am.
It's available, ma'am.
It's available, ma'am. Sorry.
Yeah, I have fixed it now. Okay. So in the arrays, we have to declare, so it's not 10, right? So I said if it's 10, we write it 10 inside brackets, inside square brackets. That's very important. Then we have to use for loops. I hope you can remember about this for loops. I quickly touched on this one the other day. So this is a good chance where we can go through it again, right? So in a for loop, we have 3 components, right? So when you take this array, so it says it got 10, 4, 5, 6, 7, 8, 9, 10. Okay. So now what we are going to yeah. So so if we are going to put some values here. Right. So in the 10, so we are starting from count is, so we are going to maintain a counter. This is the initial value, right? And then, so the name is number array count is set to 0. Right? And then, so this will be, no, this is number 1. Check number 2. Where the count is less than 10, obviously, right? Because count is now 0, so it's less than 10. So then execute what's inside the array, inside the curly brackets. So you assign the value 0, set element at location I to 0. So count, now it's count 0, value is 0. Then count plus plus. Count plus plus. What does this mean? Hope you all can remember.
Adding 1.
It's adding 1, yes. So next the count value, so number 4, it will be what? 1. So after that you check Now, number 5, that's count is less than 10. You don't go to count is 0, right? So 1 is less than 10, yes. So we come inside. Now, number array 2. Number array 1. So now, as I mentioned, arrays, the index starts with 0, 0, 1, 2, 3, likewise. Okay. So now the index is not 0. Now it increased to 1. So then one value, we need to set it to 0. So we'll set it to 0. See, what are we doing here? We are initializing the elements of the array called num array to 0. So we are making everything 0 here in the array. Now students, if it was one variable, it will be very easy, no? Isn't it? So let's say my num is 0. Just one line. No? Put a semicolon. Int. That's it. But see, when it's an array of elements, even to initialize the value to 0, we have to use a for loop. No? We use a for loop because the compiler, this is a derived data type from int. So you have to move, like you have to build how to execute this one. You want to initialize a value. So you can see you need to use a for loop. Right? Then, even to get the values from here, you will have to do the same thing. Right? You will have to use another for loop to get the values from here to display. Right? Even to input, you will have to use an array. And to display also, you will have to use an array. Okay. Yeah, students, you can use any online compiler, but remember for your test, you can't use those online compilers, right? You have to use this plugin that's available on the LMS, right? And if you type it there and you want to copy and paste, we will not give extra time. So you have to do within the time that is provided for you. Yeah, so this is a write a program to calculate the sum of the array elements. So we will not do this exercise. You can do it on your own, right? So check the arrays and you can do that one. We'll move to structures. Right? We will further learn about arrays during the practice session. Right? Not the first practice session because arrays will not come for the first lab. Right? So then structures. Now, what are structures? In structures in C looks like this. It's not an array, but it can use arrays as well. Here, it may look like a database, but it is not a database. But we can give store details about a particular object. Now, see here, we are storing details about the student. So it's not just one variable. See, you can, if you can look at element by element, you can see char name 55. See, name. To hold the name, we have declared a variable called char with 55 elements on it. Then to hold the NIC number, again a char data type, we have 10 digits. Then for year of birth, it's just an integer value. For email address, 15 elements of char. See students, now this structs you can use when you want to hold a lot of data for a particular object. Then whatever that we want to include here, we have to first of all declare here, right? In the struct itself, you can use arrays, you can use simple variables, that's not an issue. However, make sure you put it inside curly brackets, and a semicolon. Right? Okay. So this is an example of using a struct. This is very good program. Here it teaches you about many areas. So we have a struct named student. And one thing that I forgot to inform you, like let's say you build a structure, struct. So in this case, struct is student. Now, if you want to hold details about 5 students, we have to have struct elements like this. So I'm going to have student 1 here, then student 2, then student 3. So these are structs. Student 4, likewise. Right? Then that depends on how many student details you want to keep here. Right? So struct student 1. So for student 1, we have initialized it to null. Right? So that's one thing, that the one way that we can do is we just put it to null, everything. And then later on, add them one by one like this. So hope you can remember this string copy function. In this string copy, what we do is, we're going to say for each struct value, student 1, let's say student 1, this is the student 1, dot name. So student 1 has a name, number, year of birth, and the email address. So here, this way, we are using a different method. See, student 1 dot year of birth is 2010. This is very straightforward. Because this is like just assigning a value to a variable. That's very easy, right? But then, what do we have here? Why we need to use string copy here? Now, name, when the name is an array, right? An array, char array, you can't directly use like this. Directly assign. That's why you need to use for string copy function. So it's easier. Sorry, than using a for loop to assign a value for a struct. So you can write the struct name dot whatever the component, and see, it's Anjali Khan. That value is directly copied. This is a function, right? We discussed about this function during the day school too. So here we copy this, whatever the value in the second argument, to the first argument. Value of Anjali Khan will get assigned to student 1 dot name. Okay. And then for structs, we have to always use the student 1 dot name, student 1 dot NIC, student 1, because when you have different elements in the struct, all the student details will have different values now. It depends, right? So whenever you want to get details of student 1, you should write student 1 dot name. If you want to get details of student 2, then you need to write student 2 dot name. If you want to get NIC number, you have to put student 2 dot NIC. Likewise. Okay. Right. Then we'll move to the pointer concept. This also will be explained in detail during the practice sessions, right? Okay. So pointer concept. Now this is very important. This is an example. This also we are not going to do during the session. It's an exercise, you can do it at home. Right. So now, what is this pointer concept? Let's say in C, especially this pointer concept is very popular. A pointer is something like this. Let's say we have a variable, a pointer, let's say, so you know how to recognize it's a pointer is you see when you see this asterisk sign, right? Okay. So we have a pointer, an integer pointer of P1. What does a pointer will do? It's like this. Now you have learned about different variables of staying here. Let's say this is A, this is B. That's it, right? This can. Now, these are just variables, but a pointer variable is something like if I put A asterisk, now this is a pointer variable. That means this point to something else, some other variable. In this case, the example says int asterisk P1. That means P1 is a pointer. See, pointing to something. What is it pointing? That we have to write in the next line. So now here, you can see this is a very simple thing, nothing to do with pointers. There is a variable called result. And this variable result, you have the value 10. Fine. That's it. This is a very simple thing. And what is a pointer? We have a pointer variable, integer pointer variable, which is pointing to something, right? But we haven't assigned it yet. In this third line only, we are assigning it. We are saying, yes, we have a integer pointer and we have a variable called result. Now, this integer pointer should point to the result. So how we are going to do it is, now we're pointing, it will be pointing to the addresses. That's why we have ampersand. Ampersand means addresses. Address of the result. Now in the memory, in the memory, we have values. In the memory, we have memory addresses. So here what we are doing is this pointer value is pointing. Pointing to an address. Not pointing to a value, but it's pointing to an address, ampersand result. Okay. So let's quickly touch this one. Don't worry if you clearly don't understand this one, you can read the book and then we will again discuss during our practice sessions. Right? So let's say result is an integer. Okay. Result. And we have the pointer P1. P1. Result got the value 10. And with this line, we are saying P1 set to address of result. P1 is set to address of result by using the ampersand sign. Right? Now, the address of result, we can actually type this program and see. Then the value of P1, the address of P1. We'll run this program and see what are the values of this. Okay. Let me get this. Right. Give me a few minutes. result. So we put value 10 to the result, right? And then I'm going to make P1 pointing to this result. Set to the address. Now let's get the printfs statements. Written down. The address of the result. So because you are using a pointer value, we will have to use the placeholder here, pointer. So we are getting the address. So make sure we write the ampersand result. Then we get the value of P1. Let's get the value of P1. The address of P1, it's going to, this is not the value of P1, the address of P1. Okay, so we can get the address of P1 and see. Okay, so wait, before we'll get the value of result as well. The value of result variable. Suppose the result. Okay, now let's see. Right, see the value of result is 10 because we have assigned the value 10, right? Then the address of the result, we say ampersand result. So because it's the address, if you put an ampersand sign, it means the address, is this one. This is the memory location. Okay, this is the address. Then I hope that you all can understand here. We get the ampersand result. This is the address. That's what is the value here. Right? Then in this line number 8, what happens? In line number 8, the ampersand result get assigned to P1. So that's why we want to check the value of P1. Value of P1. Can you see that these two are the same? students? Because we are assigning, no? We get the ampersand, the address of the result, and then we assign it, no? So what, from this line number 8, what we will do is we have P1 pointer, right? We have P1 pointer pointing to the result variable. So if I print P1, I will not get the value 10. That is what you have to understand. Students, did you all get what I said? You will not get 10 here if you save the value of P1, right? Although P1 we say is equal to ampersand result. We say ampersand result. If the ampersand was not there, yes, then it will be 10. But now it's the address. So that's why you get this address similar to this one. Okay. Then the address of P1 is completely something else. Right? So we have P pointer, sorry, P1 pointer, and we have the result variable. So pointer P1 is pointing to result. Okay, students. So did you all understand this program? Hope you got an idea. What I would advise for you all is please read the book, and then when we get another chance when you're doing the practice session, we'll look into this one deep. Okay. Right, now let's move to the next section. Now you can do that. So these are linked lists. So I will not go through this one because this is data structures. We can discuss about this later, but then just a quick thing to tell about linked list is it's a list that is linked, right? So these are linked. This is a list. You have in a linked list, you will have nodes where you have data and pointing to the next. So A, B, C, D in this case are the data values, right? So it's pointing to the next. It's a list, right? So further you can read on the book and get it. But remember, arrays, linked lists are that thing, arrays, linked lists, queues, stack, they are all coming under data structures. Let's move to the next section. This is a very important section now. Students, I think you all know that now the C programming part for the day schools are over, right? We will go for requirement engineering. So in the software engineering book, right? I think I mentioned that there are different plans. We are discussing about software process model, right? So, in the requirement engineering is one section of it. It's actually comes in the first phase, because requirements are some things that we must identify in a system. Introduction to requirement engineering. Right. This is now, let's say we are talking about a computer system. Now in a computer system, the system services, constraints, goals are established by consultation with system users. Right. Now let's think about building a new ATM machine for a bank. Then we have to gather requirements for the system. What are necessary, isn't it? So when we are building a software system for a company, we need to know what do they really need. What is in the system? What are the services they are planning to provide? What are the constraints? What are the goals? Right? So now they need to be defined, clearly defined. That's what we are going to learn now. Right? So when we are trying to understand this, what functions need to be executed? Okay, the ATM machine, are we allowing the customers, bank customers, to check their balance? Are we going to give a mini statement after every transaction? Are we going to just show the balance or not? See, now when you use different ATM machines that are available in this country, we can see some ATM machines, after you withdraw money, the available balance will be displayed. Some of the bank ATMs, they don't show the balance. Now, I will notice if I'll have many cards in different banks, or if you use the same card in different ATM machines, you may notice that their interfaces are different. No? So let's say Ceylon Bank, Sampath Bank, Bank of Ceylon, People's Bank, or their commercial bank, they have different interfaces and their functionalities are different. So how they identify these things? They consult this, whoever who's using the system requirements must be identified now. So then the development staff also have to, first of all, before going for the development, you have to understand the requirements with the users. So the software requirements engineering is concerned with elicitation, analysis, specification, and validation of software requirements. So we'll see what do you mean by elicitation, what do you mean by analysis, what do you mean by specification and validation. Right? It is widely acknowledged within the software industry that software engineering projects are critically vulnerable when these activities are performed poorly. That means if you do not understand the requirements properly, what will happen at the end of the day is you will get a poorly performed software. Okay, software requirements. So we'll have a brief introduction now. First, we need to carry a feasible study, often carried out separate. Right? Then comes the requirements elicitation. First, you conduct a feasible study, then collect the requirements, then analyze them, then specify them, then go for validations. So let's have a look at requirements elicitation. So what is requirements elicitation? Requirements elicitation is, we have to first of all find out where the software requirements come from and how the software engineer can collect these requirements. Okay? So, where the software requirements come from and how the software engineer can collect those requirements. So, there are elicitation techniques, interviews, scenarios, prototypes, facilitated meetings, observation. That means in order to collect data from the for the system, to come up with the requirements, to identify the requirements of the system, you need to do a big study So study, how can you do the study? There are very defined methods, like you can do interviews, you can interview the customer, you can interview the people who are using the system, you can interview the operational staff, right? Then scenarios, so study scenarios, come up with prototypes. We can have meetings, observations. It's another very important requirement elicitation method. So let's say you're going to build a point of sale software system for a supermarket. You can observe how things work, right? And then come up with a better idea or collect data as required. Requirement analysis. Now, requirement analysis, we can get the requirements identified with the data flow diagram. Now, in the book, students, there are data flow diagrams written. So please check that one, right? Identify, when you get a data flow diagram, you identify the data flow diagram with business process, you draw a circle, and data flowing from one process to another using edges. Then indicate who interacts with outside, with customers, and we can have many levels likewise. Let me get this book and show you how one there. So in the data flow diagram is like heavily used in the software engineering system, was used a lot earlier, but it's used to show others how a system works. Right? I understand how a current system works. See here, read the book session 5, requirement analysis, see, with data flow diagram and UML. So we will not draw UML diagrams in this day school. We will draw use cases next week, right? Not next week, sorry, in the next day school session. So here, this is a context diagram of a data flow where you put the main system here. So this is Kumudu Garage follow-up system, and that's in a circle you put it, and then whoever who interacts, like receptionist, mechanic, manager, customer, stock control system. These things, these are outsiders, not outsiders, inside the system who will be interacting with the system. So you put them, and then the data flow. So it's very name itself, data flow, how the data flows from one place to another. See, from the system, a job sheet goes to the mechanic. From the system, manager get use parts and time, and then, use parts and times, manager report to the system. Then the system gives reminders of stock level to the manager. Right. See, from this system, an invoice is generated and given to the customer. Right? From the system, an invoice is generated and given to the customer. Overdue invoice reminder is given to the customer. Right? So it's very simple DFDs, but now this is a DFD with a level 1. That means you go in deep and then you draw with the data sources here, where you want to store the data. Data sources are like this. Likewise. Okay. So let's get back to the presentation. So you can draw use case diagrams to show how the system works. And also you can use case diagram. Now in this course, we are focusing a lot on use case diagrams. Use case diagrams comes under Unified Modeling Language, UML. This is mainly goes with object-oriented design concepts. However, so these use cases are also very easy to draw, but then you have to identify the system carefully. So when you have a system, you have to identify business processes and identify actors who are involved in it. Okay, so for an example, the manager of a supermarket wants to have the day-to-day processing of the supermarket automated. According to him, following requirements are given. So can all of you all read this one? So it says the supermarket has a variety of food items. Customers pick up items from different shelves in required quantities and present these items at checkpoint operator. The operator enters the code number of these items along with respective units. Now, things that we can program, we need to identify, right? So picking up things from different shelves is something that we can't do, right? That is something that customer should do. Then the operator enters the code number of these items along with the respective units. At the end of sales transaction, an invoice is printed. Invoice should indicate total amount payable. When the amount is paid, the system gets a record starting the particular invoice is paid. So these are the requirements, right? Then the system also maintains an inventory of all items in the supermarket. The manager upon query should be able to see the inventory. So manager should see the inventory details. Then in order to support inventory management, the inventory of an item should be decreased whenever an item is sold. It's a process, right? The system should also support the option by giving an employee can update the inventory when a new supply. The manager should be able to change the selling price of any item as prices of the item vary on a day-to-day basis. Okay, now students, let's try to see who are the actors involved in this system. Now, an actors means the ones who will be doing some work, and processes are things that will be done, right? So in this case, it's very clear when you read this thing that we have to have a checkout operator, right? Then we have to have a manager, isn't it? We can have the checkout operator, we can have the manager, because they have some work to do. Yes. Then we can have customers, right? So clients or customers, checkout operators, and the managers. So these are the people who are known as actors. So actors in a use case diagram is shown like this. Now I will not draw use case diagram now. As mentioned, we'll do it the next day school, but I will just give an idea. So we'll have the actors like this, and the processes will be written in like this. Okay. So in a process block, we will write all what the processes or the functions like print invoice. Okay. So customer can view invoice. Like that. Okay. So you have a disk. Wait. Yeah, we will do this part. Requirements validation. So as I mentioned to you, we will draw the use case diagrams from the next one, right? So somehow what you have to know is when you do after you do the requirements elicitation, that means you collect data, you have to use a graphical method, and then you have to identify the requirements properly. Then after that, you come to requirements validation. Now, the requirements may be validated to ensure that the software engineer has understood the requirements. And it is also important to verify that a requirement document conforms to company standard and that is understandable, consistent, complete. Now, so in requirements validation is we validate whether these are correct or not. So how we can do it? So there are different ways like requirement reviews, prototyping, model validation, acceptance tests. These will be like in deeply, you will study in requirement engineering when you do it in the next year, right? So one thing that we need to know is how we identify the requirements, like how we write the requirements. So writing good requirements is very important. Need. Always ask. If there is a doubt about the necessity of a requirement, then you should ask, what is the worst thing that could happen if this requirement were not included? If you do not find an answer of any consequence, then you probably do not read the requirement. So writing good requirements is important, but that doesn't mean you have to have everything in your requirement document. So you need to first of all identify whether it's needed. And you verify. As you write a requirement, determine how you will verify it. So that means you have to understand whether it's possible for you to verify this one. Can we check this one? Can we verify it with the customer? Can we verify it with the existing employees? Likewise. Then clarity. When you're writing the requirements, it have to be very clear. Each requirement should express a single thought, be concise and simple. It is important that the requirement not be misunderstood and it must be unambiguous. That means it cannot have multiple meanings. It should have only one meaning. When you write a requirement, it's like writing a C program, right? It should be very clear. You should write the requirement, express a single thought only, and you can't have multiple meanings of it. Simple sentences will often suffix for a good requirement. Right. Common problems, making bad assumptions, writing implementation. That means how we are going to implement instead of what is the requirement. So most of the time I have seen when we work with student projects, they think, okay, how are we going to implement? Are we going to use for front end, but are we going to use for how we are going to use it? How we are going to implement, how this problem is, when we have a software problem to solve, most of the time students always think we have to think how we are going to solve it. But instead of that, the most important thing is what are we going to solve? What are the requirements? Not about the softwares you are going to use. They of course plays a major role, right? But then before that, it's very important you identify what are the requirements. Describing operations instead of writing requirements. Yeah. So when we write these requirements, you don't write how we process it or the operation step by step. Rather, you should write the requirements. Then using incorrect terms, incorrect sentence, bad grammar, missing requirements, overspecified. So these are some issues that you find in the industry when system, like in software engineering field, these are some common problems if you do not specify the requirements properly. Right, bad assumptions. So bad assumptions occur either because requirement authors do not have access to sufficient information or the information does not exist. So these are bad assumptions. So you can eliminate this by documenting the information critical to the program. Yeah. So then we come to the implementation. A specification was released for the development of requirements management, implementation. Now, as I mentioned earlier, now you identify the requirements, right? and then you verify the requirements, then come for the implementation. Yeah, so always specifications should state what is needed, not how it is to be provided. So, but it's a common mistake because they always think about the implementation as how it is, how we are going to deliver it. So the most important thing in requirement engineering part is that you specify what is needed. Okay, so let's see something wrong. This is wrong, so, right? The system shall support the training coordinating, defining training scenarios. So that way of writing is wrong, and you have to write like this. This is just a simple scenario. The system shall provide input screens for defining training scenarios. The system shall provide automated training scenario processes. See, writing a correct requirement should be very clear like this. Not use words like support. What do you mean by support? Right? So that's why it's very important to use correct terms. Then bad grammar. If you use bad grammar, you risk that the reader will misinterpret what is stated. So that's why it is very important you use correct grammar, because otherwise it will give a wrong idea, right? Omissions. Now, many requirements are missed because the team writing the requirements is focused on only one part of the system. So in requirement engineering, one other thing is, if the requirement and the team who is working on this requirements engineering, if they focus only on one part, then that is also an issue. Okay, right. So yeah, so we'll see about functional and non-functional requirement. Now, this is a very important thing, students. I have noticed this at many places when we ask students to write functional and non-functional requirements. Functional, of course, many of you all understand it properly, like, let's say, functional requirements, login, print receipt, backup a system. Those are functional requirements. What are non-functional requirements? Non-functional requirements are like things that are not directly identified as a system. Now, let's say in a bank ATM system, functional requirements will be withdrawing money, checking the balance, getting the mini statement, right? Those are functional requirements. But what are non-functional requirements? Check the balance within 1 minute. See, it's related to functional requirements, but it's not a functional requirement. Be able to access a record in 1 millisecond from a database of 30,000 records. See, that's we have to write in a measurable way. Don't ever write now. See, you need to have security. That's an unfunctional requirement, but you don't write security. You don't write quick response time. You write the system should respond in 60 seconds, or the system should respond in 1 millisecond. Whatever the value, you have to write. Okay, so when collecting requirements, you have to, that's why it's very important when collecting requirements, you discuss with the users of the system, right? Now, please remember this section, functional and non-functional requirements. Keep this in mind when you read the book, and next time, the next day's course, we will discuss about writing, drawing use case diagrams. Okay. Okay, students, I have an exit ticket for you all. So please do this activity, and then you can leave. Slides will not be provided. You can't send the slides, please. I will not send the slides in the chat. You will have to do an activity given in the LMS, then you will be able to get the slides and the recording. Please read the books. Okay, please read the book. Students, did you all get this exit ticket? Did you all get the exit ticket?
Yes, ma'am.
Okay, can you all please do this? Do it. Is it possible for you all to access this?
No, ma'am.
It's not available.
No, ma'am.
Let me see.
Madam, it's available.
Okay. Well, I think this may not be able to. You may not be able to give answers if you have not used your OUSL email. Yeah. Is it okay for others?
Yes, ma'am.
It's okay, right? If you use your OUSL email, you can. Yes, you will get permission because you will have to. Please log into the OUSL email. Then you will get it. You will have to get it's a OUSL email is a Gmail, so you will get permission. Okay. So if anyone of you all completed giving answers, please let me know. So the ones who have not given, who doesn't have access, in the same browser, please open your OUSL email and then try this one, then you will be able to do it, okay?
Ma'am.
Okay, I think many of you all have done it, right? Okay, students, then thank you so much for attending today's day school. There will be a practice session tomorrow from 10:30 to